Have you ever heard of creatine? Most people who work out have heard about the supplement and the type of controversy it may cause. See, though it is known primarily as a supplement, it is actually a natural substance found in many of the foods we eat, such as seafood and red meat. People who are vegetarian or vegan must then rely on creatine supplements to get the proper amount of it, since it is only usually found in these meats. In turn, creatine is stored in muscles primarily for quick bursts of energy. Other widely known benefits include building muscle, promoting recovery and performance, and preventing injuries. The most common ways athletes may use creatine is through creatine loading. The athlete you see here is named Jeff Seed. He is just one of many examples of men in bodybuilding who use creatine. Many of them believe it is advantageous to achieve maximum strength and physique goals, as seen in his physique in this picture. Though it may seem harmless, there are many advocates for its usage, while many others oppose its usage, believing too much can be harmful. We're here to present and determine the real usefulness with an unbiased point of view, as many of these advocates may be sponsored by companies whose main goal is to make as much money as possible. As is seen with the influence of marketing in the fitness industry, information and common notions can be skewed with everyone. In this presentation, we will present an unbiased review of the chemical supplement creatine, which is used by many to enhance physical performance and stamina. This presentation will determine under what conditions creatine can be useful, as well as harmful to the human body and why, given its chemical composition and natural properties, and the effect it may have on athletes. What is creatine, and what is it used for? Creatine is a natural substance used to enhance muscle mass and physical performance. It is highly accessible, meaning it is found in powders, tablets, energy bars, drinks, and mixes. It's very safe for short-term consumption, and it's also very popular among student athletes. Another example of creatine usage is seen with this athlete, specifically in the context of Olympic powerlifting. While the last picture of Jeff Seed that I had shown you related to physique and how an athlete looks, this example serves to show the contribution creatine may have to the performance of an athlete, even at the Olympic level. So the previously mentioned benefits of bursts of energy and performance come to show and be quite explicit at high levels of competition. Similarly, as seen here, this athlete is a vegan who relied heavily on creatine supplements to properly complement his training, eventually allowing him to break the world record in the most weight carried by a human over 10 meters, specifically 555 kilograms. As such, what these examples come to show is just how critical, effective, and how widely used creatine is in the fitness and lifting industries.
So, the chemical name for creatine is methylguanidine acetic acid, and it's made up of 3 amino acids, which are arginine, glycine, and methionine. And pretty much we have 3 ATPs, we have 3 energy systems in our body, and you've probably heard of the aerobic and anaerobic set of energy systems, but we have a third one called the phosphocreatine system, or the ATP-CP system, and it's used for all-out fast, high-intensity activity. And pretty much this energy system gives our bodies a whole lot of energy in a very short amount of time. It gives it to us very fast, but it can't do it for a long time. So, where does creatine come from? Well, our bodies produce their own creatine, and we can also get it in our diets. The foods with the highest concentration of creatine are seafoods and red meat. For example, a whole pound of uncooked red meat contains 2 pounds of creatine, and a whole pound of salmon or tuna contains around 4.5 grams of creatine. But these numbers decrease when the food is cooked. And so to get the therapeutic benefits of creatine of creatine, you need to consume 5 grams a day of it. And trying to consume 5 grams a day of creatine through diet alone is unpractical, and it is probably very unhealthy for you. If you wish to get the benefits of saturated creatine in your cells, you should supplement it. So how exactly does creatine supplementation affect the body? Well, creatine produces ATP, which provides energy for muscle contractions through the phosphocreatine energy system. The reaction is phosphocreatine plus ADP plus a hydrogen ion produces ATP plus creatine. And muscles contract by using a cross bridge between actin and myosin. And the actin contains calcium ions, which latch onto the high energy myosin head before any contraction, and it creates a cross bridge. ATP also develops from ADP, and it solidifies the bridge between the actin and myosin, and this has multiple benefits for exercise and athletes. So what are the reported benefits of creatine supplementation? Well, people with cognitive decline or neurological disorders can see a benefit from creatine supplementation. Vegetarians and vegans can also see cognitive benefits from creatine supplementation since they do not get any creatine in their diets, since creatine is mainly found in animal products. For individuals who lift weights, it is recommended that they supplement with creatine since there are many benefits from it. For example, creatine will aid in bouts of physical activity of fewer than 30 seconds significantly, but it has also been shown to improve moderate activity for longer than 30 seconds. In terms of working out, creatine appears to increase the maximum amount of weight an individual can put on a barbell by around 8%. Additionally, a 14% increase is expected for the number of repetitions an individual can do at a given load. After creatine supplementation, a 15-pound increase in a 1-rep max for the bench press is expected, and a 20-pound increase for a 1-rep max in the squat is also expected. To see these benefits, one must supplement creatine for around 30 days, consuming around 5 grams of creatine a day. However, you can see the benefits of creatine supplementation faster if you consume more creatine for a short amount of time. For example, you can see the benefits of creatine supplementation after 6 days if the individual supplements 25 grams a day, and then he continues with 5 grams a day after the initial 6-day period. This is not needed, but if someone wants to see the benefits fast, this is what they can do. There are other forms of creatine besides creatine monohydrate, but creatine monohydrate has been the one that has been shown to be the most beneficial, and it has the most scientific data supporting its benefits. Other ways that creatine can help people with lifting weights is increasing the total amount of volume that they lift. Muscle protein synthesis and muscle hypertrophy has been shown to have a direct link with workout volume, and since an individual's performance has been increased, since after supplementation a person can put more weight on a bar and they can use heavier loads while training, it will give them more volume at the gym, and so they will be able to grow faster. After supplementation, people can expect to gain around 2 to 4 pounds of weight right after supplementing creatine, and this is due to water saturation in the cells, in their muscle cells, since creatine tends to absorb and hydrate cells.
Creatine supplementation can also be very beneficial to those suffering from conditions that are caused by or cause weakened muscles, such as heart failure, Huntington's disease, neuromuscular disorders, high cholesterol, and cognitive decline as well, since creatine provides excess energy and works to strengthen muscles. So now you might be wondering what the drawbacks to creatine are. Well, long-term effects of creatine consumption have not yet been researched, though it is assumed that too much creatine consumed over extended periods of time without any way of releasing all excess energy gained can be harmful to the body, for instance causing muscle pain from forced contractions, or etc. Short-term effects of creatine consumption have been researched, and it is proved to be very safe. A side effect of creatine is that it drives water into muscle cells, and therefore it is necessary to drink a lot of water when supplementing. Otherwise, users can become incredibly dehydrated, resulting in severe cramps and muscle pain. And another drawback to creatine is increased weight gain, mostly from muscle growth. Some scientists speculate additional drawbacks to increased creatine supplementation, such that the body might stop naturally producing creatine if it begins to heavily rely on outside supplements, which can be harmful. Another disadvantage is that creatine helps mostly with activities that require short bursts of energy, rather than activities that require longer times, such as long-distance running, for example. Going back to the issue with water and dehydration. So, the chemical synthesis of ATP from ADP and a phosphate yields condensation, aka the removal of water. Since creatine supplementation provides the phosphate that reacts with the ADP to form ATP, that results in the removal of H2O. And therefore, those who take creatine supplements must hydrate extensively. Otherwise, they will become dehydrated, they will lose weight, and it is an actual problem that some people who do supplement creatine will purposefully not drink any water so that they can reach a weight class. However, this is not safe and should not be done. So in conclusion, creatine is a natural chemical compound found in seafood and red meat that forms ATP used to boost energy for muscle contractions and thus can be used as a healthy supplement for increased muscle mass and improved physical performance. Creatine is not harmful if consumed regularly under the right conditions to dispose of excess energy gained through its consumption. This presentation has reviewed the chemistry of creatine and has determined how and under what circumstances the supplement can be beneficial and or harmful to the human physique. And these are our sources.